Welcome to the deep dive. We're diving into the world of large language models today.
Those AI systems that can write code.
Yeah! Compose poems, even answer those tricky trivia questions.
Right.
But what if I told you there's a new approach that's,
Emerging.
yes, emerging and challenging the status quo?
Yeah, that's right. We're going beyond the familiar world of transformer models and exploring something called ARWKV.
ARWKV.
It's shaking things up by utilizing a technology that some might consider old school,
Oh, really?
recurrent neural networks.
Okay, so for those of us who don't spend our days, coding AI,
Sure.
what exactly a wine is an LLM? And why should we be excited about this ARWKV?
Okay, so imagine a computer program that's absorbed an entire library's worth of information.
Wow.
That's essentially what an LLM is.
Okay.
It's learned patterns in language, the
Right.
relationships between words, and it can use that knowledge to generate human-like text. Like chatbots, AI assistants, and even those incredibly realistic deepfakes you might have seen online.
Right.
That's the power of LLMs in action.
Okay.
Now, the thing about ARWKBV is that it achieves this power
Yeah.
in a more efficient and accessible way, potentially opening up AI development to a much wider audience.
So it's like giving the power of these large language models to everyone,
Exactly.
not just those with massive data centers and resources.
Exactly. One of the biggest hurdles with the current dominant model, the transformer,
Yeah.
is the sheer amount of computational power needed to train it.
Okay.
Imagine trying to run a high-performance gaming PC
Right.
on a single AA battery.
Oh, wow.
It just wouldn't work.
No.
But ARWKV, by leveraging the strengths of RNNs and a technique called knowledge distillation,
Knowledge distillation.
offers a way to train powerful LLMs on more modest hardware.
So it's not just making them smaller, but actually changing the way they learn. Can you break down how ARWKV uses this knowledge distillation to learn from a larger model?
Okay, think of it like an apprentice learning from a master craftsman.
Okay.
The apprentice ARWKV learns the key techniques and skills from the master.
Right.
In this case, a pre-trained transformer model, like Quinn 2.5,
Queer 2.5.
but does so in a more efficient way that requires fewer resources.
Okay.
Instead of trying to replicate the master's every move,
Yeah.
the apprentice focuses on capturing the essence of their knowledge.
That's a fascinating way to approach it.
Yeah.
But how does ARWKV actually work? What's going on under the hood to make it so efficient?
It replaces the self-attention mechanism
Okay.
found in transformers with something called a time-mixing module.
Time mixing module.
Imagine reading a sentence.
Okay.
You build understanding word by word,
Right.
carrying the context with you.
Uh-huh.
ARWKV's time-mixing module, which is based on the RWKV7 architecture,
RWKV7.
works similarly.
Okay.
It processes information sequentially, like reading a sentence,
Yeah.
allowing it to understand and generate text in a way that's both powerful and resource-light.
So it's not just about throwing more computing power at the problem, but about approaching it in a smarter, more strategic way.
Absolutely, and the results are impressive,
Oh.
even with fewer training tokens.
Okay.
ARWKV performs comparably to much larger transformer models on certain benchmarks.
Really?
In fact, a smaller version of ARWKV actually achieved perfect results in a 16K passkey retrieval task.
Perfect results. Now, I'll admit, passkey retrieval sounds a bit technical.
Yeah.
Could you explain that in a way that even I can understand? And why is this perfect result so significant?
Okay, imagine trying to find a single specific key on a giant keychain with thousands of keys.
Okay.
That's essentially what passkey retrieval is.
Right.
Finding the right key, a passkey in this case,
Uh-huh.
in a massive data set.
Okay.
And ARWKV doing this flawlessly demonstrates its incredible ability to store and retrieve information accurately, even with a smaller model size.
That's pretty impressive.
This could have major implications for security and personalized AI applications.
Okay, now that's starting to sound truly groundbreaking.
Yeah.
So we've got this efficient and powerful new approach to LLMs.
Right.
What's next for ARWKV? Where do we go from here?
The researchers behind ARWKV are already exploring ways to extend its capabilities even further.
Oh, wow.
They're looking at extending its context length,
Okay.
meaning it could handle even longer pieces of text and more complex tasks.
So it could basically take on even more.
Yeah.
All right.
And they're working on aligning it more closely with user preferences,
Okay.
making it even more useful and intuitive in real-world applications.
So they're basically fine-tuning it
Yeah.
to be even better and more user-friendly.
Exactly.
But is this all just about making language models better? Or are there bigger possibilities here?
The potential goes far beyond language.
Okay.
The researchers believe that ARWKV could be applied to other areas of AI development, potentially leading to more powerful and accessible AI tools for everyone.
Wow.
Imagine, for instance, ARWKV's efficiency being applied to things like mixture of experts frameworks.
Mixture of experts. That's a new one for me. What does that even mean?
Think of it like a team of specialized doctors,
Okay.
each with their own area of expertise, working together to diagnose and treat a patient.
Right.
In AI, a mixture of experts framework uses multiple specialized experts, each handling the specific part of a task.
Okay.
And ARWKV could be like the conductor, orchestrating these experts to work together seamlessly.
So it's not just one AI doing everything, but a whole team of specialized AI working together.
Exactly.
I'm starting to see how this could lead to some truly incredible advancements.
Yeah.
But before we get ahead of ourselves, let's take a step back and really unpack what makes ARWKV so revolutionary.
Okay.
Exactly. We've thrown around a lot of exciting ideas and possibilities, but I think it's time to break down the key takeaways and really understand why this new approach is such a big deal.
All right. First and foremost, ARWKV demonstrates that we don't always need bigger and more complex models to achieve groundbreaking results. By focusing on efficiency and leveraging the strengths of a seemingly older technology like RNNs, ARWKV shows us that innovation can come from unexpected places.
It's like finding a hidden gem in your grandmother's attic.
Yeah.
Something beautiful and valuable that was overlooked for years.
Yeah.
So ARWKV challenges the assumption that bigger is always better when it comes to AI.
Precisely. It highlights the importance of exploring alternative approaches and not being afraid to challenge conventional wisdom.
Right.
And speaking of challenging assumptions, ARWKV also tackles the issue of accessibility in AI research.
Right. We talked earlier about how the massive computing power needed to train traditional LLMs creates a barrier to entry for many researchers and developers. So ARWKV could be a game changer by making AI development more democratic.
Exactly. Imagine a world where cutting-edge AI research isn't limited to large tech companies and well-funded institutions, but is open to anyone with a good idea and a decent computer. ARWKV could make that a reality.
It's like opening up the world of AI to a whole new generation of innovators. Regardless of their background or resources, that's incredibly exciting.
It is, and this increased accessibility could lead to a surge in creativity and diversity of thought in the field.
Oh, wow.
We might see entirely new approaches to AI development tailored to specific needs and applications that we haven't even thought of yet.
It's like planting seeds in a fertile field. ARWKV could spark a blossoming of AI innovation across the globe.
Yeah.
But let's delve a little deeper into the technical side of things.
Sure.
You mentioned that ARWKV's time mixing module is based on the RWKV7 architecture.
Yes.
Can you elaborate on that a bit? What makes RWKV7 so special?
RWKV7 is a type of RNN that's been making waves in the AI community because of its unique ability to handle long sequences of information without losing track of the context. Think of it like having a photographic memory for text. Traditional RNNs sometimes struggle with long pieces of text because they can forget earlier parts of the sequence, leading to a loss of understanding.
So it's like having a conversation with someone who has a short attention span. They might forget what you said a few sentences ago, and the conversation becomes disjointed.
Exactly.
RWKV7 avoids that problem.
Exactly. It uses a clever combination of mathematical techniques that allow it to retain information over long distances, making it ideal for tasks like passkey retrieval or understanding complex narratives.
Wow.
And by incorporating this powerful architecture into its time-mixing module, ARWKV inherits this ability to process information sequentially without sacrificing efficiency.
It's like combining the long-term memory of an elephant with the agility of a cheetah.
Right.
That's a pretty impressive combination. But the research paper also mentioned some other technical details like transition matrices and eigenvalues. Can you break those down for us without getting too lost in the mathematical weeds?
I'll do my best. Think of a transition matrix as a map of the model's internal workings.
Okay.
It describes how information flows through the RNN, like tracing the paths of neurons firing in the brain.
Interesting.
Eigenvalues are special numbers associated with this matrix. They tell us something about the long-term behavior of the model, like how well it remembers information over time.
So it's like some information sticks in the model's memory while other information fades away?
That's a great analogy.
Okay.
And what's interesting is that RWKV7 has a wider range of these eigen values than traditional RNNs, suggesting that it's better at capturing both short-term and long-term dependencies in the data. It's like having a more nuanced and sophisticated memory system.
It's fascinating how much complexity there is beneath the surface of these AI models, but
Yeah.
I'm glad we're able to unpack some of these concepts and make them a bit more accessible.
Me too. And speaking of accessibility, the researchers behind ARWKV didn't just stop at making the model itself more efficient. They also explored ways to streamline the training process.
Oh, really?
One technique they used is called gate-free training.
Okay, gate-free training. That sounds intriguing. Tell me more.
In traditional RNNs, gates are mechanisms that control the flow of information through the network, like traffic lights directing cars at an intersection.
Okay.
But the researchers found that in the case of ARWKV, removing these gates entirely actually improved performance.
So it's like removing the traffic lights and letting the cars flow more freely.
Right.
It seems counterintuitive that removing something would make it better.
It does, but that's what makes this discovery so interesting. It suggests that sometimes simpler solutions can be more effective.
Right.
And it highlights the importance of challenging assumptions and experimenting with new ideas.
It's a great reminder that innovation often comes from thinking outside the box.
Yeah.
But let's shift gears a bit and talk about the real-world implications of all this. We've touched on how ARWKV could democratize AI development,
Yeah.
but what are some specific examples of how it could be used in everyday life?
Imagine a world where AI models are no longer confined to massive data centers,
Okay.
but can run efficiently on devices like your smartphone or laptop.
Oh, wow.
ARWKV could make that possible.
So instead of relying on the cloud, we could have powerful AI running locally on our devices.
Exactly.
Yeah.
And that opens up a whole new realm of possibilities.
Oh.
For example, ARWKV could power personalized AI assistants that are more responsive, more intelligent, and more capable of understanding your individual needs.
It's like having a super smart sidekick.
Yeah.
Who's always there to help you out, whether you're trying to write an email, schedule an appointment, or just have a casual conversation.
Right.
And all of this happening right on your phone without relying on an internet connection.
Precisely. And it goes beyond personal assistance.
Okay.
ARWKV could also revolutionize fields like education, healthcare, and customer service. Imagine AI tutors that can adapt to each student's learning style, providing personalized guidance and support.
That would be incredible, especially for students who might not have access to traditional tutoring services.
Exactly. And in healthcare, ARWKV could help doctors diagnose diseases more accurately, analyze medical images, and even develop personalized treatment plans,
Wow.
all while ensuring patient privacy by keeping sensitive data on local devices.
Wow. We're talking about potentially improving and even saving lives with this technology.
Yeah.
But what about the ethical considerations of making AI so accessible? Could there be unintended consequences?
It's a valid concern, and it's something that researchers and developers need to consider carefully as AI becomes more pervasive in our lives.
Right.
But let's focus on the potential benefits for now.
All right, fair enough. So we've got personalized AI assistants, revolutionary education tools, life-saving medical applications.
Yeah.
What other possibilities are there? Does ARWKV have any limitations?
The potential applications of ARWKV are vast, but just like any new technology, it has areas where it can be improved.
Okay.
One area the researchers are focusing on is extending its context length.
So right now there's a limit to how much information ARWKV can handle at once.
Yes, but they're working on ways to push those boundaries.
Okay.
A longer context length would allow ARWKV to handle even more complex tasks, understand longer pieces of text, and potentially even generate entire novels or screenplays.
That's incredible. I can already imagine the possibilities for creative writing and storytelling.
Right.
But what about other limitations? Are there any concerns about its accuracy or potential biases?
Accuracy and bias are critical considerations for any AI system, and ARWKV is no exception. The researchers are actively working on techniques to align ARWKV more closely with human values
Okay.
and ensure that it generates outputs that are both accurate and unbiased.
So they're essentially trying to make sure that ARWKV is a force for good in the world.
Exactly. It's all about developing AI that is not only powerful and efficient, but also responsible and ethical.
Right.
And speaking of pushing the boundaries of AI, the research paper also mentions applying ARWKV to multimodal architectures,
Multimodal architectures.
which sounds pretty futuristic.
I'm all ears. Multimodal architectures sounds like something straight out of a science fiction movie.
It might sound futuristic, but it's closer than you think.
Mm-hmm.
Multimodal architectures refer to AI models that can process and understand different types of data, like text, images, audio, and even video. It's like giving AI multiple senses to perceive the world.
So instead of just understanding language, it could understand images, sounds, and even videos.
Exactly. And ARWKV, with its efficiency and ability to handle sequential data, could play a key role in these multimodal systems. For instance, it could be used to analyze how the words in a movie script relate to the visuals on screen,
Right.
leading to a deeper understanding of storytelling and media creation.
That's fascinating. It could revolutionize the way we create and experience media.
Right.
We could have AI systems that not only understand the content of a movie, but also the emotional impact of the visuals and music.
Precisely. And it goes beyond just understanding.
Okay.
Imagine using ARWKV in a multimodal system to generate new forms of content, such as videos with automatically generated captions or music that responds to the emotions expressed in a piece of writing.
So we could have AI that creates art that is truly immersive and multisensory.
Exactly.
Yeah.
We're talking about AI that can understand and interact with the world in a way that's much closer to how humans do,
Wow.
opening up a whole new dimension of possibilities. But before we get too lost in the future,
Yeah, let's bring it back to the present and summarize what we've learned about ARWKV so far.
all right, what are your key takeaways from our discussion?
Well, we've covered a lot of ground, from the technical nuts and bolts to the potential applications, and even dipped our toes into the ethical considerations. I think the biggest thing for me is this idea of ARWKV breaking down barriers in AI development.
That's certainly a core aspect. It's about democratizing access to this powerful technology, empowering individuals and smaller organizations to contribute to the field. We've seen how resource-intensive traditional LLMs are almost like a high-stakes game reserved for the big players. ARWKV, on the other hand, feels like it's leveling the playing field, allowing more diverse voices and ideas to shape the future of AI.
It's like switching from a massive fuel-guzzling machine to a sleek, energy-efficient model.
Right.
You still get incredible power, but it's suddenly within reach for many more people.
Exactly. And with that wider participation, we could see a burst of innovation.
Oh, wow.
Imagine students, independent researchers, and startups all contributing their unique perspectives and solutions to the AI landscape.
Yeah.
This could lead to AI applications tailored to specific communities, industries, and even individual needs, rather than being driven solely by the interests of large corporations.
It's almost like shifting from a monoculture to a thriving ecosystem.
Yeah.
With a diversity of approaches and solutions addressing a much wider range of challenges and opportunities.
Yeah.
But amidst all this excitement, it's important to remember that ARWKV is still in its early stages.
Absolutely. While the initial results are extremely promising,
Right.
there's still much research to be done.
Yeah.
The researchers themselves are very transparent about this. They're continuously exploring ways to improve ARWKV's performance, refine its training process, and address any limitations that might arise.
So it's a journey of continuous improvement and discovery.
Precisely. It's like launching a spacecraft.
Okay.
You have a clear destination in mind, but you need to constantly monitor the trajectory, make adjustments along the way, and be prepared for unexpected challenges. The same applies to ARWKV.
Right.
It's an exciting journey, and we're all eager to see where it leads.
Speaking of the journey ahead, one area that caught my attention is the researchers' exploration of extending ARWKV's context length.
Right.
What's the significance of that, and what could it unlock?
Think of context length as the model's working memory.
Okay.
It determines how much information it can hold and process at any given time. Extending that context length is like expanding the capacity of that working memory, allowing ARWKV to handle even more complex tasks and understand longer, more intricate pieces of information.
So it's like upgrading from a small notepad to a massive whiteboard.
Yeah.
You suddenly have much more space to work with and can tackle more ambitious projects.
Right.
What kind of projects are we talking about in the AI world?
With an extended context length, ARWKV could potentially analyze entire books, research papers, or even code repositories, extracting insights and generating summaries that would be impossible for a human to do in a reasonable amount of time.
So we're not just talking about summarizing news articles anymore,
Right.
but comprehending and analyzing vast amounts of information that would take humans weeks, months, or even years to process.
Exactly. And think about the potential applications in scientific research, historical analysis, or even legal research. Imagine having an AI that can sift through mountains of data and pinpoint the most relevant and insightful information.
It's almost like having a research assistant with superhuman reading and comprehension abilities.
Yeah.
And we've also talked about ARWKV's potential in multimodal architectures, processing and understanding not just text, but also images, audio, and video.
Right. And extending the context length in those multimodal systems could lead to AI that understands not just the individual elements,
Right.
but the intricate relationships between them. Imagine an AI that can not only recognize the objects in a video,
Yeah.
but also understand the emotions conveyed through facial expressions, the tone of voice, and the overall narrative being presented.
We're talking about AI that can truly comprehend and interpret human communication in all its complexity and nuance, moving beyond simple recognition to a much deeper level of understanding.
Yes.
It's both exciting and a bit daunting to think about the implications.
Yeah.
But for now, we've reached the end of our deep dive into the fascinating world of ARWKV.
It's been a pleasure exploring this groundbreaking technology with you and our listeners. We've covered a lot of ground, from the technical details to the mind-boggling possibilities, and I hope you've come away with a deeper appreciation for the potential of ARWKV to reshape the AI landscape.
I know I have. And for our listeners who are eager to dive deeper, we've included links to the research paper and other resources in the show notes.
Yes.
Be sure to check those out.
And remember, this is just the beginning of the ARWKV story. Who knows what amazing applications and innovations will emerge as this technology continues to evolve?
Exactly. The future of AI is full of possibilities, and ARWKV might just be the key to unlocking some of the most exciting ones.
Absolutely.
Thanks for joining us on the Deep Dive.
It was my pleasure.
Until next time, keep exploring, keep learning, and keep asking questions. The world of knowledge is vast and always unfolding.
Yeah.
And as we've seen today, sometimes the most groundbreaking discoveries come from the most unexpected places. So stay curious,